Hello students, let's do natural numbers and whole numbers, exercise 4a. This is on page number 30 and we have to fill in the blanks here. So we are studying about natural numbers and whole numbers. So the first statement here is the smallest natural number is. Now we are studying about natural numbers and whole numbers, and natural numbers are all counting numbers like 1, 2, 3, 4 and so on. These are all natural numbers. So natural numbers begin from 1. So the question here is the smallest natural number is, and the smallest one here is 1. So let's write that in the blank. It's 1. Now the next one, the next sentence is the smallest whole number is. Whole numbers start from 0. 0, 1, 2, 3 and so on. These are whole numbers. So the question is the smallest whole number, and the smallest whole number is 0. So we have it there. Now the largest natural number, Now these are natural numbers, and the natural numbers go on and on up to infinity. That means it is limitless. You can't count it. You can't find the largest natural number. It's not possible to get the largest natural number or the largest whole number. So it goes on and on. So here the largest natural number is, you write either infinity or it's not possible to find the largest natural number. Next one, the largest whole number. That is also infinity or it's not possible to find the largest whole number. We can find the smallest but not the largest number. Now look at this sentence. All natural numbers are, now these are natural numbers, 1, 2, 3, 4, and they're all whole numbers also, 1, 2, 3 and so on, isn't it? So all natural numbers are whole numbers. All natural numbers, since they start from 1, they can all be whole numbers also. Now next one, all whole numbers are not natural numbers. Why do we say that? Because 0 is the smallest whole number, isn't it? Now 0 is not a natural number, isn't it? So you cannot say that whole numbers are natural numbers. You can say natural numbers are whole numbers, but whole numbers are not natural numbers. Next one, successor of 4099 is, now what do we mean by successor? Successor is the number that comes after. So suppose I have 4099. To find the number that comes after, I add 1 to it. Okay, so 9 plus 1 is 10 carry 1. 9 plus 1 is 10 carry 1. 1 here and 4. So what is the successor of 4099? 4100. So that is our answer. Next one, the predecessor of 4330. Okay, the predecessor of 4330. Predecessor means the number that comes before 4330. To find the number that comes before, we minus 1. Okay, so let's do that subtraction. Here we have to borrow, so this is 2 and 10. 10 minus 1 is 9 and I have 2 there, 3 and 4. 4329. So that is the predecessor of 4330. Question 2, state true or false. First statement is whole numbers are closed for addition. Now what does this mean? It means when you have two whole numbers, now let's take 2 and 3, two whole numbers. When you add up these, if your answer is also a whole number, now 2 plus 3 is 5, our answer is also a whole number, then you say that whole numbers are closed for addition. This is the closure property. That is, when two whole numbers on adding gives you another whole number, then you say that these whole numbers are closed for addition. So this statement, whole numbers are closed for addition, is true. If A and B are any two whole numbers, then A plus b is not a whole number is what this statement is telling us. Now let's give a and b simple numbers as their values. Okay, let's say a is 2 and b is 3. Now let's see what this means. A plus b. 2 plus 3 is how much? 5, and 5 is a whole number. But what does this statement say? A plus b is not a whole number. That means this statement is false. Let's write that false. Third one. What does this statement say? If a and b are any two whole numbers, then a plus b is equal to b plus a. Is this part true? We're going to find out now. So let's give a again the value. This time let's say 5. And let's say b is 4. Okay, so 5 and 4 are the values of a and b respectively. Then let's look at this statement. What does it say here? A plus b is equal to b plus a, and a we said is 5 and b we said is 4. 5 plus 4 is 9, and on the other side what does it say? B plus a. B is 4 and a is 5. 4 plus 5 is 9. 9 is equal to 9, isn't it? So this part is true, that is a plus b is equal to b plus a. So this statement is true. Let's write that true. So this is actually another property of addition of whole numbers where the sum is the same even if you change the order. So whether you write a plus b or you write b plus a, your answer is going to be the same. So this is the commutative property. Question 4. 0 plus 18 is equal to 18 plus 0 is this statement. Let's see if it is true. 0 plus 18 is how much? 18. And this side 18 plus 0 is 18. So this statement is true, isn't it? The left side is equal to the right side. So let's write that true. Question 5. Addition of whole numbers is associative. What is this associative property? Let's learn it with the help of an example. Let's take three whole numbers, 2, 3 and 4. Okay, and we're talking about addition of whole numbers. So let's add them all up. Now, if I find the sum of 2 plus 3, that is if I group 2 plus 3 and then add 4 to it, let's see what I get. So let me find the sum of 2 plus 3. 2 plus 3 is 5. 5 plus 4, I get 9. Now, what if on the other side, I take the same three numbers, 2 plus 3 plus 4. This time I'm going to find the sum of 3 plus 4. Okay, initially here we found the sum of 2 plus 3. We grouped 2 and 3. On the other side, I'm going to find the sum of 3 plus 4 and group them. So the order has changed. Let's see if the answers are the same. So 2 plus 3 plus 4 is 7. And 2 plus 7 is 9, and you can see 9 is equal to 9. So this is the associative property, and addition of whole numbers is associative. So this statement is also true. Let's write that true. Question 6. 10 plus 12 plus 16 is equal to 10 plus 12 plus 16. The sum of 10 and 12, then you add 16. And they're saying that is also equal to 10 plus the sum of 12 plus 16. Now let's see if this is true or false. So let's add up 10 plus 12, this part, 10 plus 12 plus 16. Let's add it all up. 10 plus 12 plus 16. What do we get? 2 plus 6 is 8. 1, 2, 3. We've got 38. So this part is 38. So we'll rub this and we'll write this part as 38. So here we have got 38. Now let's go to the other side and see whether it's equal. So here we have to find the sum of these two because it's put in brackets. 10 plus 12 is 22. 22 plus 16. So let's add that 16 here plus, now 2 plus 6 is 8. 2 plus 1 is 3. So here also we've got 38. So let me rub this and write only 38 there. So this part we've got 38. Now let's go to the other side. Here it says 10 plus 12 plus 16. How much is 12 plus 16? That's 28. 10 plus 28, what do we get? 8 1 plus 2 is 3. Here also we get 38. So let me write that. So after adding, we found this also to be 38. So this statement, as you can see, is true because here after adding I got 38. This one after adding I got 38. And here the order is changed. I still have got 38. That means this statement for question 6 is true. Let's write that. True. Question 3, we have fill in the blanks here. So let's answer these questions. Question 1, we have 54 plus 234 equals 234 plus, it's 54 itself because here we have one set of numbers. What we are doing here is we're just changing the order of the numbers and their sum will be equal. So this is the commutative property which says when you add up two whole numbers, even if you change the order, the sum is going to be the same. So the answer here is 54. So let's write that 54. Next one, we have 332 plus 497. So 332 plus 497. And on the other side, we have only 332. So what is missing? 497 is missing, which we are going to write here. So here also, we're just changing the order and writing, and the sum will be the same, commutative property. Next one, 286 plus 0 will give you back the same number, 286. Next one, 286 into 1. Any number into 1 will give you back the same number, that is 286. 286. Question 5. Here A plus the sum of B plus C. So the other side it will be the sum of A plus, what is missing here is B. A plus B, the sum of A plus B plus C. So this is the associative property which says even if you change the order when you have three numbers, your sum will still be the same. Next one, we are going to verify that question 1, 3 plus the sum of 5 plus 4 is equal to the sum of 3 plus 5 plus 4. Verify means we're going to show that the left hand side is equal to the right hand side. So this is the left hand side. So first let's simplify and find the value of the left hand side and see what we get. So this is the left hand side. So what do we have there? 3 plus the sum of 5 plus 4. So this is equal to 3 plus, what is the sum of 5 plus 4? 9. 3 plus 9 is 12. So left hand side we have 12. Now let's see the right hand side. Here we have the sum of 3 plus 5. The sum of 3 and 5 plus 4. This is equal to 3 plus 5 is 8 plus 4. 8 plus 4 is 12. So here can you see the left hand side is equal to the right hand side. So hence this is verified. So we have verified that the left hand side is equal to the right hand side. So you have to say hence verified. Question 2. 8 into the sum of 8 plus 0 is equal to 8 into 8 plus 8 into 0. So here let's see how to work this out. So again let's start with the left hand side. What does the left hand side say? It says 8 into 8 plus 0. So that's in brackets. So we're going to work that out first. 8 into 8 plus 0 is 8. 8 8s are 64. So on the left hand side we've got 64. On the right hand side what do we have? So here we have 8 into 8 plus 8 into 0. So we can do this. 8 into 8 is 64 plus 8 into 0 is 8 zeros are 0. So here what do we have? 64. So as you can see, the left hand side is 64 and the right hand side is also 64. So we have verified that the left hand side is equal to the right hand side. Hence this is verified. So the left hand side here, though it's put differently, is equal to the right hand side. Question 3. 7 plus 6. The sum of 7 and 6 into 10 is equal to 7 into 10 plus 6 into 10. So let's do that now. Now here we have the left hand side. So let's work out the left hand side first. So what do we have this? 7 plus 6. The sum of that into 10. So let's work out the left hand side. The sum of 7 and 6. 7 plus 6 is 13. 13 into 10. 13 into 10 is 130. So on the left hand side we have 130. Let's see what we have on the right hand side. Here we have 7 into 10 plus 6 into 10. So let's write that 7 into 10 plus 6 into 10. So we have to do the multiplication first. So we can do 7 into 10 and 6 into 10. So 7 into 10 is 70 plus 6 into 10 is 60. 70 plus 60 is 130. So on the left hand side we have 130. On the right hand side also we have 130. So the left hand side is equal to the right hand side. Hence this has been verified. So this is the answer. The left hand side is equal to the right hand side, and we have verified this question which is given here, this statement. Question 4. The 15 minus 12, the difference of 15 and 12 into 18 is equal to 15 into 18 minus 12 into 18. So let's take the left hand side first. So what is the left hand side? This is the left hand side. 15 minus 12, that is the difference of 15 and 12, and that we multiply into 18. So what do we have here? 15 minus 12 is 3. 3 into 18. So let's multiply 18 into 3. So what do we have? 3 8s are 24, carry 2. 3 1s are 3, 4, 5. So on the left hand side we have 54. Now let's see on the right hand side. Now here can you see 15 into 18 minus 12 into 18. We can use the distributive property here to make our working easier. Now look out for which number is common. Now 15 into 18, 12 into 18, which is the number that is common. As you can see, 18 is common, isn't it? So we can rewrite that in a different way. So this is the right hand side. I'm going to take 18 and I'm going to write it first. And since it's multiplication, put the multiplication sign. Now I'm going to have brackets, and what is left? Now here we have 15 into 18, isn't it? We have 15 into 18 minus 12 into 18, and we have written the common factor 18 outside. So what is left? 15 minus 12. 15 minus 12 is left, which I'm going to write in the brackets. 15 minus 12. So this will be 18 into 15 minus 12 is 3. 18 into 3 is what we just multiplied. Here we multiplied 18 into 3 and we got 54. So here 18 into 3 is 54. So the right hand side is also 54. That means the left hand side is equal to the right hand side, and this also has been verified. So we write hence verified. Now here I have done the distributive property. Okay, so I have taken the common factor which was 18 and I put the other numbers 15 and minus 12 inside 15 minus 12. You can also do it another way where you multiply 15 into 18 and 12 into 18 and subtract the two answers. But the distributive property makes our working easier. Question 5. 16 plus 0 is 16. Okay, let's see if that is true. Okay, we're going to verify. So the left hand side and we have the right hand side. Left hand side is 16 plus 0. 16 plus 0 is 16. Now the right hand side we have 16. So as you can see, left hand side is 16. Right hand side is also 16. So left hand side is equal to the right hand side, hence verified. So we have found out that the left hand side is equal to the right hand side, and we have verified this. Question 6. 23 plus minus 23 is equal to 0. So here also we have our left hand side. We'll work that out first and see. 23 plus minus 23. So this is 23. Now when you see minus before a bracket, like you see here, this one will remain the same. So it is minus 23. 23 minus 23 is how much? 0. Now right hand side, what do we have on the right hand side? We have a 0. So as you can see, the left hand side is equal to the right hand side. So this also has been verified. So we have written that here, hence verified. So this also we have verified to be correct. State true or false. So now again we have some statements. We're going to say if they are true or false. The sum of two odd numbers is an odd number. So let's take an example. Odd numbers are numbers like 1, 3, 5, 7. You're leaving out all the even numbers. So let's take two odd numbers. Two odd numbers will be 1 and 3. And sum means add. So 1 plus 3 is 4. The sum of two odd numbers, 1 and 3, is an even number. It's not an odd number. So this statement is false. Let's write that. False. The sum of two odd numbers is an even number. Okay, so let's take another two examples. Two odd numbers, 3 is 1, 5 is another one. Sum means add. 3 plus 5 is 8 and 8 is an even number. Now what does this statement say? The sum of two odd numbers like this is an even number. True. This statement is true. Let's write that. True. Third one. The sum of two even numbers is an even number. Okay, let's take two even numbers. 2 and 4. Okay, 2 plus 4. These are two even numbers. Let's add it up. 2 plus 4 is 6. 6 is also an even number. So this statement, the sum of two even numbers is an even number, is true. True. Fourth one, the sum of two even numbers is an odd number. We just did an example and we found the sum of two even numbers is an even number. Here it says the sum of two even numbers is an odd number, which is false. Next one, the sum of an even number and an odd number is an odd number. Now let's try that. Let's take an even number 2 and an odd number 3. Let's add it up. 2 plus 3 is 5. That is also an odd number. So this statement is correct. Let's take another example. Even number. Let's take 10. 10 is an even number. Plus, let's take an odd number, say 5. 10 plus 5 is 15. And the answer is an odd number. So this statement is true. Question 6. Every whole number is a natural number. Now this we learned earlier. Whole numbers start from 0, 1, 2 and so on. And natural numbers start from 1, 2, 3. So every whole number is not a natural number because 0 is a whole number but it's not a natural number. So this statement is false. Question 7. Every natural number is a whole number. Okay, so natural numbers are numbers that start from 1, 1, 2, 3 and so on. Whole numbers start from 0, 1, 2, 3 and so on. So you can see 1, 2, 3 is there here also. That means every natural number is a whole number. That statement is true. So let's write that. True. Question 8. Every whole number plus 0 is equal to the whole number itself. Okay, let's take an example. Every whole number, let's take 7. 7 is a whole number plus 0 is equal to 7, which is equal to the whole number itself. So this statement which says every whole number plus 0 is equal to the whole number itself is true. Because we took an example, 7 is a whole number. When we added 0, we got back 7. So this statement is true. Question 9. Every whole number into 1 is equal to the whole number itself. So again, let's take an example. Every whole number. Okay, 9 is a whole number into 1 is equal to 9, which is the whole number itself. So every whole number into 1, we did this, is equal to the whole number itself. We get back the same whole number. So this statement is true. Question 10. Commutativity and associativity are properties of natural numbers and whole numbers both. Now, the commutative property we learned and the associative property we learned. Now, these are properties of natural numbers and whole numbers. Now, that statement is false because they are properties of addition of natural numbers and whole numbers. So, this statement is false. And the next question is, commutativity and associativity are properties of addition. So addition, the word addition is missing there. Here we have the word addition for natural and whole numbers both. This statement is true. Question 12. If x is a whole number, then minus x is also a whole number. Let's just take an example. Now suppose I take, say, 12. 12 is a whole number. Then minus 12. Is minus 12 a whole number? No, because we know whole numbers start from 0 and goes to the right on a number line if you draw one, whereas minus 12 will come to the left of 0. So minus 12 is not a whole number. So this statement, if x is a whole number, then minus x is also a whole number, is false. So we've completed all our true or false questions and we've completed the exercise also. So with this we come to the end of this video. Thank you, children.